Hello and welcome everyone to my nice little YouTube channel about VST development. This time I am revealing to you that I am working on sort of a delay module that I want to use, which is supposed to be a WoW emulation of a tape. So like WoW and Flutter. just to explain the goal very quickly. WoW and Flutter are terms when you're talking about tape degradation, and WoW describes the pitch fluctuations of a tape, while Flutter describes the amplitude fluctuations. So in order to make fluctuations in general, you have to implement a vibrato, which is basically a delay with an LFO on the delay time, and the LFO must be slightly random. So I went on and told people about my idea, and someone sent me a paper that said that tape fluctuation works by having a sine wave playing more or less at 4 Hz constantly, but like with these fluctuations sometimes going up very quickly. And we all know these tape fluctuations, or more like everyone who has ever owned a tape knows them, that sometimes they can also go really high, like I would say up to 13 Hz. So what did I do to enable myself to realize this? As you can see, there is no delay in here yet. So I have not finished this class already. I have another implementation of that where I did finish everything, but I didn't like it. So I started off at the beginning again, and now it's much cleaner. So what did I start with? Yeah, well, some constants and some other constants for the specific classes that will occur. I defined a range system with a start end, and it has a distance when you instantiate it or when you set it new. We have a randomizer that can do different stuff by calling the operator. We have a utils function that gets the amount of channels, samples, and sample rate to so that we can give that to all our other classes just by giving it the utils. Also some useful functions. Whenever I have a global function that can be used anywhere else, I just put it into utils, and then it's everywhere. So we have an interpolation class that knows how to interpolate, and a bunch of interpolation classes that inherit from interpolation and then they can interpolate in different ways on the given data. And then we have the certainty namespace that I was talking about in my last video, which can get a term, and then it can give you a certainty, or more like a random value in the range of the certainties. And I gave the method some new details in the meantime. I will talk about that later, I think. Then we have a table, which is basically just a lookup table, and we use that for giving, so that we can define the waveform, because then we can just say, yeah, we want to put a function into the table, and that will be the waveform with some interpolation. Now the waveform itself can have different basic waveforms that are described here, or we can make a custom waveform with a lambda. So we can also use this with any other types of wavetables and stuff. Then we have the oscillator that has a waveform, but we don't use it yet. Currently we just have an oscillator class that we can use what's the concern here? And enum, yeah, sometimes I use enums instead of enum class because it's just nicer and you don't have to cast it, so that's pretty nice, I guess. And then we have a phase, which is basically just like a saw oscillator in the simplest way possible, and it has the opportunity to give you back a boolean about whether it just reset it or not, because we will need that later. And we have a smoothing class, but it's currently not used yet, so let's just not talk about it. We have a random phase, and the video will be a lot about the random phase. And we have the tape class in general that currently just has the phase and processes the phase onto our audio buffer. But the more we will continue to grow this namespace, the more this tape object will do broader things than just that. So I just put the current thing I am working into this struct all the time. Yeah, so let's start. But this time, let's not start with the lowest stuff, but with the highest stuff, so you can really see what's going on here. First of all, let us play back the audio. But I want to encourage you to turn down your volume a lot, because we are playing back the phase, and this is a value between 0 and 1 that just jumps back from 1 to 0 when it reaches 1, so that's bad for your speakers if you play too loud. So turn them down. 3, 2, 1. Okay, you had enough time to turn it down or pause the video. And you could also already see in the console that we get frequency values around 4, and sometimes it goes up to 10. It can also go up to 14, I think. No, 13. Okay, cool. Yes. So how? Let's see. The tape gets the utils and the phase gets the utils as well. When we prepare to play, the utils gets all its information. We can set the oscillator gain. Actually, it should be called phase gain at the moment, because I renamed this to random phase. The random oscillator will come later. Well, whatever. I'm not using set oscillator gain at the moment anyway. Much more important is set oscillator frequency range, which should be called set phase frequency range. But whatever, because this will set the frequency range of phase, as you've seen. And then we can also set the oscillator waveform either with the waveform enum, it's up here somewhere, yeah, or with a custom lambda if custom is chosen. Yeah, so nothing too fancy in here. And the process block, I'm currently not using these if statements, but I just put them there just in case that I need them. And then we have the sample loop and the channel loop, and we get the wave from the phase and we just play it back. So there is nothing fancy in this method, it's just for testing currently. And now the utils is instantiated here, and then we only get the reference to the phase so that everywhere the same data is available. Now RandPhase gets the utils, also gives the utils forward to the phase, saves the utils into a reference, gets a certainty from our certainty namespace, the generator, the certainty generator, and it gets a frequency range which is on 0 and 1 by default. So we can reset the frequency range in here, and then we can process the sample. if phase, and you know phase gives you a boolean about whether or not it just reset, then let's get a new frequency, a new random frequency. So we get a new frequency from the certainty by calling this operator, and then we can just type in any certainty that we like, which is in this case highly unlikely frequency range. Why can we do this? Because then we set the frequency and then we give back the phase so we can hear it. But let's first talk about this expression here. The certainty is in here, generator, and then we have the overloader operator. We overload the operator, give it a range, and then we say range start plus whatever the certainties gets times the distance of the range. So if we go back here, we see the range starts at 4 and then it goes to 13. And this means basically minimum 4 plus whatever you get out of this times the rest of the range, right? So if we say it's highly unlikely, then we mean that it will mostly stay on 4 Hertz and sometimes it will jump up to 13. So this is a very nice way to access a probability, because it's not just a numerical way to phrase it, but with terms, and that makes it very nice to use, and also nice because the values that you get out of this are actually really natural, and because they are based on psychologically measured data, as you can see in my other video. Yeah, so what does the phase do? We already saw it. The phase just goes on the increment when you set the frequency, and then it spits out whether or not it just came back. Yeah, so the next step will be actually adding an oscillator, a sine wave oscillator that gets the phase of the random phase, and it will map the output of it to its waveform data, which will be stored in a table. Where was the table? Table. Yeah, you saw the table here. Whatever. So this is the next step. But we will have to smoothen the values first, and I prepared a little class for that, but I didn't test it yet, so let's not talk about it. Yeah. So yeah, let's not talk about all this stuff, and also not about the interpolation at the moment. That's not so important for this video. Maybe the randomizer, no, that's also not important. What really is important is the certainty. I already talked about it in my last video, but I added a very important aspect. You can still take these terms and get a certainty from these terms. Oh, I have to let my cat inside. Kleine Katze, komm herein, miau. Ich muss jetzt mein Video weitermachen hier. Jo, ist so. She's always very excited when she comes home in the evening. Yeah, okay, so we have this certainties count and certainties per certainty, and I noticed that when you just access the array with only 46 certainties and all of them have values like 95% or 90% or 85%, then you can't really get an output like 81.376 or something. So what I did was I added an order to the generator. So we get the raw data, we prepare the certainties just like in the last video, but instead of just letting them be like that, we upscale the certainties with the order, which means we put the size order times certainty per certainty, and we will later access the array with the size instead of certainties per certainty. And if the order is not 1, then we have to do a lot of stuff, and else we can just leave it the way it is. We make a new array with vector floats just like the certainties, and we call it new data, and then we go through all the samples of we go through all the certainties, and we reserve the space of the size. We instantiate a spline interpolator with the actual certainties array, and we give it the size certainties per certainty. And then, since the spline interpolation has already prepared everything we need for us, we only have to go through all the samples of our new data and calculate the index from this index, and also from the old size and the new size, to get a nice index value for this. And then we can just say new data, C in place back, spline interpolation index, and at the end we will overwrite the certainties with our new data and throw away the new data. One thing though that I just noticed that does not work in here yet, I think, is, but maybe I'm wrong about that, but I just noticed that if I don't manually sort the certainties before doing this, then the spline interpolation might yield some very weird values. So I should definitely add this to my implementation before trusting this method once and for all. Well, so now let's see that in practice. We have the RandPhase, we get the certainty, and we instantiate it with the number 8, just so we have something to start with. Actually, let's go up here and see where we put this. Maybe we put this here. We just define a new category, which we call certainties const. Static const exp certainties order, because I really like to have all the little variables, the developer variables, that will not be available to the user but only to the developer up here. So when I want to change them, I only have to go up and do this stuff instead of into the classes. And now I can just go here and put the static const exp int into this. Yeah. And then we can just access the certainty normally, give it the frequency range, and boom, we get the right values, which makes it really nice to use this class, and a very nicely readable and still performant. Yeah. So this is how the generator works now, and I think it's pretty cool. What I also love about this implementation is we have the raw data here, the txt file, and if I ever decided to just make my own survey and extend the findings of this study myself, then all I have to do is replace this txt file with a new txt file of the new data and put a new value into this, which represents the new amount of data for each certainty. And if I maybe even change the terms, then I can also just change the number of certainties count, and it will instantly work again with the new data. So that makes this really nice to use as well. And now, after I've changed one thing or the other, let's play back this again and enjoy the frequency debug So turn down the speakers again, I guess. Yeah. turn up the speakers again. Now, except if you don't want to listen to my voice, but just see the code. Yeah, I did not implement the sorting for the certainty array yet, and it already gives me very believable values for the term highly unlikely. You can really see how it is highly unlikely to get a value up there. It's mostly, even if it goes up, it's like 11 and 12, but never on 13, and or most likely not even close. So this is really a nice way to access a probability, and it seems to work pretty fine already. That's why I made this video, because this is really cool and a really nice way to make something mathematical more accessible, I guess. Yeah, so that's a nice way to phrase it. And that was the video for today. See ya.